Welcome to Corral Copper. We recently had the pleasure of hosting a large group of geologists for a site visit, bringing together professionals from across the industry with a shared interest in the project. The day was a great opportunity to walk the site, exchange ideas, and take a closer look at the geology that makes Corral Copper so compelling. We'd like to extend a sincere thank you to everyone who joined us, and a special thanks to the Arizona Geological Society for organizing the field trip and helping bring us all together. For those who weren't able to attend, we hope this video offers a useful introduction to Corral Copper and provides a glimpse into the potential we're working to unlock.
We'll go up the trace of the Musso Fault, and our first stop will be up here in the north part of the district in the holiday zone. I'll do a short traverse here through some of the alteration and I'll explain some of the structure going on up here. Then we'll come down here, and I've got to traverse through this alteration into the Cortland Fold, this is our herb zone here. So we'll do a traverse here, hopefully. And then we'll stop and look at this Osterman Breccia zone. And then head down to Ringo, look at some of the sections through here, and a short traverse into both of these mineralized or altered intrusive rocks. So. And then I've got, so the front is the Borrego alteration suite. The back, or the west side of the table, is the intrusive suite. I think I'll talk about that more in the afternoon. But it's useful to compare what you see in the core with what's on the table. If you look at page 37 of your guidebook, there's a summary map where we're all our field stops, and we're up here at FT1 in the holiday zone. So we're going to take a short traverse up the road to the lowest mine dump, and I'll do some arm waving geology there, trying to point out the salient structural features and the mineralization features of the district. And the stop is actually on top of an intense mineralization or alteration with some I think we'll be standing on 124 meters of 0.5% copper when we get up to the top of the mine dump there. Alteration is the iron oxides, the red and orange areas are just dominant jarosite and iron oxide dominant alteration, where the Abrigo has been completely decalcified, argillized, and destroyed. So visually, if you guys have been to Bisbee, I'm sure a lot of it looks just like Bisbee, pretty much for the same reason. A lot of pyrite oxidation and supergene fluids being generated. To the west, the bold resistant outcrops are all Bolsa. The regional strike and dip is the strike's about north-south. Everything's dipping about 60 degrees to the east in this area here. But there are a lot of structural disruptions to the west. The last bold resistant outcrop there is Bolsa, dipping 80 to 50 degrees to the east, overlain by altered Abrigo to the left of it. There's a high angle normal fault down dropping the lowest Bolsa hill compared to the next Bolsa hill, and then basically every saddle is a fault, down dropping things. But there is a broad Bolsa fold with essentially vertical to overturn bedding in the lower slope. You can see it sort of flattening and rolling over at the top, but there's another thrust plane at the top of that too. So it's a really complex area.
So we are looking at least at 3 faults here.
Yeah.
3 times.
The Bolsa is repeated 4 times. So we are at the second stop, FT2, and you're on page 37. This is the ERP zone. We're kind of in the core of what we're calling the ERP zone. I had originally planned on a traverse from that mine dump over some kind of neat features where all those diggings are up to here, but it's just not going to work in the interest of time. So I'm giving you the abbreviated version here. one of the main structural features I wanted to show from this perspective is this really complex structural geometry that you can see on the slope here. So the top of the ridge is the Bolsa. It's in a low angle thrust fault. They're southwest dipping low angle faults. You can actually see one of the fault planes. There's a mine dump there at the bottom of a quartzite cliff. It's got a flat planar surface on it. That is essentially the bottom thrust of the fault zone. And it has thrust Bolsa over Bolsa and Bolsa over Abrigo. So very complex. And when there's Bolsa over Bolsa, you really have to pay attention to bedding attitudes. But there's multiple stacked thrusts as you go up to the top of the ridge there. So what we're interested in the Abrigo formation, and this is one of the best exposures of some of the complexity of fold complexity in the Abrigo. Where I wanted to take you was on a low angle thrust fault here, which is where all those diggings are. It's there's an intense zone of deformation with essentially overturned Abrigo on top of the regional dip. And there's extensive copper oxide mineralization that was mined kind of by open cuts along the thrust plane here. There's a normal fault. It's actually high angle. This is just a trace of it kind of cutting this system, but there's a down-drop block of probably preserved mineralization near where the copper tanks are here. But, yeah, step back there. Okay, sorry. Got it. So, you can see this, this is the regional Abrigo dip here. It's actually overturned and almost flat, coming completely around on it. It looks like to me was a fold and it got refolded with this thrusting event. Very complex, but doesn't really matter for exploration. What does matter is this dotted orange line here that corresponds with the color change. That's the alteration front. Essentially, this diagram here, this argillized and silicified materials on top. This is all carbonate. So here's the alteration front here. There's our extensive copper oxide workings at that alteration front. It looks like two different lithologies, but if you look at the outcrop, you'll see the stratification going right through that contact. One looks like a hornfels, one side looks like a hornfels, the other's got carbonate. And there's really distinct vegetation anomalies. There's a Marisol plant, I think, that is this plant here. It only grows on carbonate lithologies, whereas the bare areas are the sulfide generating material. So you can see, basically, you could map that contact from the vegetation as well. So, common theme, high-grade copper oxides at that alteration front. There's a series of quartz latite sills. They've been dated in the Jurassic. They transect the whole trend here from south of Star Hill and Rico all the way up to where we first started this morning. They're sills, they're strongly silicified, they're conformable with bedding, and they're actually involved in the folds here. But I think they're important in that the alteration is more or less proximal to these Jurassic sills. So I'll get another section here.
Is there high pyrite associated with those sills, like at Bisbee?
This one? Within the sills, no. A lot of quartz, Stockport quartz veining. The pyrite's in the wall rock margin. So we're halfway in between these two drill holes here. That pad there where all the orange is this hole here, 30 meters of 0.4% copper right at the surface, all oxide, in decalcified, argillized and silicified Abrigo. There's kind of a barren area through here of just where the carbonate and epidote scarring. And then what we're going to walk up into is this area here with a very nice quartz latite sill and the alteration proximal and the copper mineralization proximal to the sill. Primarily dominated by copper bell intrusion porphyry. So what we've been driving through here is propylatized copper bell. Pretty boring. It's kind of a regional alteration. The only exception here is this zone here. It's a structurally confined zone of silicic alteration, quartz sericite, pyrite, and breccias. We are right here at the tail end of this. Chris Osterman, our technical advisor, sampled this and there's some gold in it. And he said, you might want to take a look at that. So it turns out that's kind of the tail of the tiger. It's an 800-meter strike length zone going from here to the east. It's got all sorts of echelon splays to it. This is a scanned copy that did not print well of the map that was on the wall this morning. So as you can imagine, bright green is propylatized copper bell. The purple, garish purple blue is quartz sericite pyrite alteration. And then there's internally, there's silicified zones. And kind of the key part of this was, this is all copper bell, but within these structural zones, there are breccias, heterolithic breccias, rounded class of bolsa, intrusives we don't even see on the surface. There's some altar debris. So these breccia dikes have brought up Paleozoic rocks from below. So they're pebble dikes essentially. I've got some good cut samples on the table there at the core shed, but clasts are truly rounded. They look like a conglomerate, but they're structurally confined. But a pretty pronounced zone going to the east, and it actually dives underneath the thrust plane with the upper Paleozoic rocks on top of the copper bell. So there's really a complex multi-stage structural mineralization story going on. I've got 2 lines in yellow here. We're going to be doing this traverse to the northwest. We'll be walking up the road, and as soon as we get around the nose there's some really nice, very strongly quartz sericite pyrite altered copper bell intrusive with a really nice stockwork in it. And then we'll go into an alteration zonation that I think is fantastic with turquoise veinlets. Quite a wide area of turquoise veinlets. So for the porphyry people, I think that's one of the more exciting traverses we have here. So we'll do that one here. It's just kind of an up and back. And then we'll actually probably just walk from the trucks and go up this road in the quartz monzonite porphyry to the breccia margin. And there are multi-stage quartz veinlets cross-cutting each other. The early stage is Americunga type veinlets, cross-cut by the other quartz veinlets. There's some very interesting breccia relationships that we can see in the road cut too.
So Maricunga veinlets style.
Yes. Here at this FT4B stop here, and you can see there's an alteration contact on my map. Again, this is a garish scan of what's on the wall. The purple is quartz sericite pyrite alteration that we've been walking across since we left the vehicles. The red is stockwork quartz veining. It's pervasive in here, but I've only put it on the maps where I've actually walked. But I have no problem infilling all this area with the quartz sericite pyrite alteration. I'm sure there's a lot more work I could do with veinlet orientations and all that, but I just had to cover ground here. The salient point on this is this whole northwest flank of Star Hill is a different alteration assemblage that we're standing on here. It's much more massive, resistant, doesn't like vegetation. There's a lot of turquoise veinlets. There's one in the road beneath us here somewhere. There's some in outcrop, and basically if you walk anywhere here, you're gonna find turquoise veinlets. And that's what's shown here in these blotches. Again, that's where I found them. There'd probably infill a lot more on that. We talked about the Nettie Fault in Ringo. I think it subcrops here in the drainage to the west. So, there's two lines of evidence for that. There's an intensely altered abrigo contact and adjacent to the intrusive, altered intrusive. And then you get up here to the north side, you go from this really strong, intense, very hard rock into a gouge zone, but it's mostly covered. So I think that, it worked out really well. Wanda modeled the fault from the drill hole orientations, and it projected right up to where it should be in the field. So I think we're pretty confident with that. So to the west in this valley, it's all covered by alluvial fan material predominantly, but there are quartz latite body sills are exposed in the low hills. The higher hills are Bolsa quartzite, but every now and then in outcrop you'll see intensely altered abrigo. So there's very few drill holes in the southern part of this trend, but where you do find abrigo, it's trashed. There's hardly any relic carbonate left in it. It's all that alteration product. A lot of gossinous material in float. And in that drainage just this side of the waste piles there's more of these Osterman style breccias. Heterolithic. They're just little pods that you can see underneath the cover. So there's a lot more going on in that area. And the geophysics, if you were to look from the surface, you'd say, well, it's all resistive. Bolsa should be dipping 60 degrees underneath us here, but the resistivity shows, well, conductivity shows a big conductor where the Bolsa should be. So it's not Bolsa underneath the surface outcrops. The geophysics negates that pretty much. But this is kind of the margin of my map area. Multiple thrust faults at the base of the hills to the west.